If your matrix is multiplied by identity matrix, you are going to get a same matrix. Find the inverse of a square matrix using elementary operations. Here the elementary operations may be row operations or column operations. So 1, 0, 0, 1 already. Here convert this to 1, that's all. Identity matrix of same order is 1, 0, 0, 1 minus A. What is A? Given matrix 3, 1 minus 1, 2. Hello, welcome to this session. I am Niranjan MJ, Faculty of Mathematics, now Vidhyaashram PU College. Now today we are going to discuss regarding invertible matrices. In the last class we have discussed regarding the symmetric and skew symmetric matrices. Today I am going to discuss regarding invertible matrices. How to find the inverse of a square matrix. Now before that, how the inverse of a square matrix exists, let us see. Now let us consider, suppose if A is a square matrix of order M, a square matrix of order M, if there exists another square matrix of order, another square matrix of same order, another square matrix B of same order, such that if you multiply these two matrices A into B is equal to B into A, then you are going to get an identity matrix. Identity matrix means 1, 0, 0, 1. If A into B, if you multiply A and B or B and A, you are going to get an identity matrix. Then B is called the inverse of A and it is denoted as A inverse. This is a very important definition. If A is a square matrix of order M and if there exists another square matrix of order B, order M, such that A into B is equal to B into A is equal to I, then B is called the inverse of A and it is denoted as A inverse. That is, if A into B is equal to I, then A inverse is equal to B. Or if A into B is equal to I, then A inverse is equal to, if A into B is equal to I or B into A is equal to I, then A inverse is equal to B, or the inverse of B is also equal to A. So A is the inverse of B or B is the inverse of A. Now let us consider a small example. Let us consider a problem. Let us take if A is equal to, let us consider a matrix. A is equal to 2, 3, 1, 2. Then another matrix B is equal to 2, minus 3, minus 1 and 2. Now let us verify. Let us multiply A, B and BA. Now if I multiply A and B, what I am going to get? A into B. What is A? 2, 3, 1, 2 into B. 2, minus 3, minus 1 and 2. Multiply this. This is equal to, if I multiply, same multiplication, matrix multiplication. First row, first column, second column. 2 into 2 is equal to 4. 3 into 1 is 3, minus 3. Again 2 into minus 6. 3 into 2 is plus 6. Again second row, first column, second column. 1 2s are 2. Again minus 2 1s are 2. Next, same row, second column. So 1 into 3 is minus 3 plus 2 into 2 is equal to 4. So this is equal to 4 minus 3 is 1, minus 6 plus 6 is 0, 2 minus 2 is equal to 0, 4 minus 3 is equal to 1. So now 1 0 0 1, this is nothing but an identity matrix. Now let us consider similarly, let us multiply B and A, B into A. Let us take B first, that is 2 minus 3 minus 1 and 2 into A. A is 2 3 1 2. So multiply this, matrix multiplication, first row, first column, second column. 2 into 2 is 4, minus 3 1s are 3. Again same row, second column. 2 into 3 is 6, minus 3 into 2 is 6. Again same second row, first column, second column. 1 into minus 2 is minus 2, plus 2 1s are 2. Again minus 3 plus 4, 2 into 2 is equal to 4. So this is equal to 4 minus 1, 4 minus 3 is 1. 6 minus 6 is equal to 0. Minus 2 plus 2 gets cancelled 0. 4 minus 3 is equal to 1. So this is equal to again an identity matrix. So see here, A into B is equal to identity matrix, B into A is equal to identity matrix. This property is satisfied. If A into B is equal to I, B into A is also equal to I, then the inverse of A, this A inverse is equal to B. The inverse of A, you can write A inverse, the inverse of A is B, that is 2 minus 3 minus 1 on 2. Or the vice versa. The inverse of B, B inverse can also be written as inverse of B is equal to 2, 3, 1, 2. So this is the inverse of a matrix A or B. That is called invertible matrix. So if A is a square matrix of order M, if there exists another square matrix B of same order, such that if A into B is equal to B into A is equal to I, an identity matrix, then B is called the inverse of A or A is called the inverse of B, and it is denoted as A inverse or B inverse. Now, this is very important concept. Now, based on this, there is one theorem that is, let us see regarding that theorem. So, invertible theorem, that is a reversal law of inverses. Reversal law of inverses. What is to prove here is A and B are invertible matrices of same order, then AB whole inverse is equal to B inverse A inverse. Reversal law of inverses. Now, according to the definition we have studied here, if you multiply any matrix A into B, if you multiply any, you know this, if A into I is equal to the same matrix, you are going to get, if your matrix is multiplied by identity matrix, you are going to get a same matrix. Suppose if you multiply by A inverse, A inverse, then you are going to get this A inverse is also equal to I. Now you know this property, the invertible property, A inverse is equal to I. If A into A inverse is equal to an identity matrix, using the definition of this invertible matrices, using this definition, by the definition of invertible matrices, by the definition of invertible matrices, by the definition of invertible matrices, this is the proof. By the definition of invertible matrices, what is the definition? A inverse is equal to I. A into A inverse is equal to I. Now let us consider this as A and A inverse. Now what is this A inverse? That is here AB, consider AB and the inverse of this AB inverse, AB whole inverse is equal to I. By the definition of invertible matrices, A inverse is equal to I. So consider AB into AB inverse is equal to I. Now pre-multiplying by A inverse, multiply by A inverse, that is pre-multiplication. Multiply by A inverse, that is pre-multiplication. So A inverse into AB, this is AB whole inverse is equal to A inverse into I. Now using associative property, interchange the bracket. If you apply associative law for this, using associative law, this can be written as A inverse into A into this B remains the same, and this AB whole inverse is equal to, you know, if you multiply any matrix with an identity matrix, you are going to get same matrix, that is A into I is equal to A. Therefore, A inverse into I is also equal to A inverse. So, using invertible property, A inverse is equal to I, then this can be written as I into B, this is same, AB whole inverse is equal to A inverse. Again, if A into I is equal to A, I into B is also equal to B. B into AB whole inverse is equal to A inverse. This is A inverse. B into AB whole inverse is equal to A inverse. Now, again multiply by B inverse, pre-multiplication. If you multiply by B inverse, then what you are going to get? B inverse into B into AB whole inverse is equal to B inverse into A inverse. Now again, using invertible property, A inverse is equal to I, B inverse is equal to I into AB whole inverse is equal to B inverse into A inverse. Again, using identity property, I into AB inverse, I into any matrix is equal to same matrix. So therefore, AB whole inverse is equal to B inverse into A inverse. This is your theorem. That is a invertible property. So reversal law of inverses. See here, what is to prove? If A and B are invertible matrices of same order, then AB inverse is equal to B inverse into A inverse. By the definition of invertible matrices, A inverse is equal to I. Consider this A and this is the inverse. So AB and inverse of AB is AB whole inverse is equal to I. Consider AB and AB inverse is AB whole inverse is equal to I. Now what is to prove is AB whole inverse is equal to B inverse A inverse. Pre-multiplying by A inverse, multiply by A inverse on left side. So A inverse into AB and AB whole inverse is equal to A inverse into I. Using associative law, A inverse into interchange the bracket. A inverse into A into B is equal to AB whole inverse is equal to A inverse into I is equal to A inverse, because A into I is equal to A inverse into I is equal to A inverse. Again, using inverse property, A inverse is equal to I into B, this remains the same, AB whole inverse is equal to A inverse. Again, using identity property, I into B is equal to B into AB inverse is equal to A. So B into AB inverse is equal to A inverse. Again, pre-multiplying by B inverse on both sides. If you multiply by B inverse on both sides, what you will get? B inverse into B into AB inverse is equal to this is equal to B inverse A inverse. So since B inverse into B, A inverse is I, means B inverse into B is equal to I, inverse property. I into AB inverse is equal to B inverse A inverse. I into AB inverse is nothing but AB inverse is equal to B into A inverse. So therefore, AB whole inverse is equal to B inverse into A inverse. This is called a reversal law of inverses. That is very important theorem in invertible matrices for 3 marks. This is a 3 marks question. Now let us come to the problems. Now based on this, we are going to find the inverse of a square matrix. To find the inverse of a square matrix using elementary operations. Here the elementary operations may be row operations or column operations. So in the previous class I explained regarding this operations, that is elementary row operations. There are certain rules. That means you can subtract any 2 rows or any column, or if you want to add, you can add any 2 rows or 2 column, and if you want to multiply by a constant, you can multiply by a constant and subtract it. So there are few rules. So interchanging, that is denoted as R1 dash, R2 dash, or C1 dash and C2 dash. Now by using elementary operation, find the inverse of the matrix A is equal to 1, 2, 2, minus 1. This is very important question for 3 marks. This is 3 marks question. So you may expect this type of problem for 3 marks. Now let us take what is given. A is equal to 1, 2, 2, minus 1. Now according to the definition, we know this. Let I is equal to I into A. Take an example. By using elementary operation, find the inverse of the matrix A is equal to 1, 2, 2, minus 1. Let us take this theorem. Let A is equal to, now we know this, A is equal to I into A. Now what is A here? This is matrix A. 1, 2, 2, minus 1 is equal to I, 1, 0, 0, 1 into A. Now this is very important and very easy. The intention is to convert this matrix into an identity matrix. 1, 0, 0, 1. Convert this to 0 and again this 2 to 0 and minus 1 to plus 1. That's all. By using elementary row operation. Now 1, 2, 2, minus 1 is equal to 1, 0, 0, 1 into A. Convert this matrix 1, 2, 2, minus 1 to an identity matrix 1, 0, 0, 1. Now it is already 1 here. Convert this to 2. Taking R2 dash is equal to R2 minus 2 into R1. If you subtract 2 with this first row, this will reduce us to 0. See here, that is So the first row will remain the same. First row is same, 1, 0. For the second row, what we are doing? R2 dash is equal to first element of R2. First element of R2. R2 dash is equal to R2 minus 2R1. First element of R2 is 2. This is 2. This is 2 minus 2 into first element is 1. That is 2 minus 2. This is equal to 0. Again, first element, second element of R2, that is minus 1 minus 2 into 2. So that is equal to minus 1 minus 4. That's equal to minus 5. This reduces to minus 5. Then coming over to this on the right hand side, 0 minus 2 into 1, that's equal to minus 2. This is minus 2. Again, 1 minus 2 into 0, that is equal to 1. So this reduces to 1. Interchanging R2 dash. R2 dash is equal to R2 minus 2 R1. First row remains the same, 1, 2, 1, 0. Then R2 minus 2 R1. 2 minus 2 into 1, that is equal to 0. Again, minus 1 in minus 1 minus 2 into 2, that's equal to minus 1 minus 4 is, this is minus 5. Whereas in this matrix, 0 minus 2 into 1 is equal to minus 2. 1 minus 2 into 0 is equal to 1. Now, this is 1, 0. Now, the intention is convert this to 1. So, for this, just divide by R2 dash. Again, R2 dash is also equal to R2 divided by minus 5. So, this becomes, so 1, 2 as it is. 0 by 5 is equal to 0. Minus 5 divided by minus 5 is plus 1. This is equal to 1, 2 as it is. And minus 2 by minus 5 is plus 2 divided by 5. And 1 by minus 5 is minus 1 divided by 5. Minus 1 divided by 5. Minus 1 divided by 5. Now, next. Now, the intention is to reduce this element 2 to 0. So, for that, what you are going to do? Again, taking R1 dash is equal to R1 dash. R1 dash is equal to R1 minus 2 into R2. So, this reduces to R1. So, R2 is same, 0, 1 is equal to, this is 2 by 5 minus 1 by 5. And see here, 1 minus R1, 1 minus 2 into 0 is equal to same, it won't changes. This becomes R2 is 2 minus 2 into R1 is 1, 2 minus 2 is equal to 0. Again, this element R2 is 1 minus 2 into 2 by 5. So, take LCM, 5 is the LCM, 5 ones are 5 minus 4, that is equal to 1 by 5. R1 dash is equal to R1 minus 2 R1. So, this is 1 minus, take here, 1 minus this element 1 minus 2 into 0 is equal to 0, 1 minus 0 is equal to 1, you are going to get 2 minus, this is 2 minus 2 into 1, 2 minus 2, you are going to get 2 minus 2 is equal to 0, this element. This is same, whereas coming over for this matrix, 1 minus 2 into 2 by 5. So, 5 ones are 5, minus 4 is 1 by 5 you are going to get. Changing this, R2 dash is, yes, if you divide by 2, R2 dash is equal to R2 by minus 5. You are going to get 1, 2, this as 1, 2, 0, minus 5 by 5 is equal to 1, and 1 to same, minus 2 by 5, minus 5 is plus 2 by 5, and 1 by minus 5 is minus 1 by 5. Now, convert this element to, yes, 1, 0, 0, 1, this element as 0. Now, for that, we are going to take the operation R1 dash is equal to R1 minus 2 into R2. So, this 1, 2 remains the same, 1, 2 same. 1, yes, 0, 1 remains the same. For this, 1, 1 minus 2 into 0 is equal to same 1. Again, 0 minus, this is 2 minus 2 into 1 is equal to 2 minus 2 is equal to 0, 1, 0. Whereas this element is 0. Okay, 1 minus 2 into 2 by 5 is equal to 5 ones are 5. This is equal to 1 by 5. This is 1 by 5. Coming over this, 0, yes, this is R1. R1 is equal to 0 minus 2 into minus 1 by 5. So this is minus into minus plus 2 by 5. So we are going to get 2 by 5 here. Now if you remove 5 common factor, 1 by 5 out, 1, 2, 2 minus 1. So this is the inverse of A, denoted as A inverse. So inverse of A is equal to 1, 2, 2 minus 1 is the inverse of the matrix. So that is inverse of matrix. I'll explain once again here. Now, by using elementary operation, find the inverse of A. A is equal to 1, 2, 2 minus 1. Let us consider by definition A is equal to I into A. What is A? 1, 2, 2 minus 1 is equal to identity matrix 1, 0, 0, 1 into A. The intention is to convert this matrix 1, 2 minus 1 as an identity matrix 1, 0, 0, 1. For that, we are going to use some basic elementary row operations. So now let us consider this operation. R2 dash is equal to R2 minus 2 into R1. So R1 remains the same. R1 1, 2, 1, 0 and A. So change this. This row is to be changed. That is R2, first element of R2 minus 2 into first element of R1. That is 2 minus 2 into R1. First element is 1. 2 minus 2 is equal to 0. Again, second element minus 1 into minus 2 times this 2. So minus 1 minus 4 is equal to minus 5. 1, 0 remains the same. Whereas here 0 minus 2 into R1. 0 minus 2 into R1 is minus 2. Again 1 minus 2 into R1, that is 0. 2 into 0 is 0. 1 minus 0 is equal to 1. Now let us convert this minus 5 as plus 1. So for this, divide by minus 5. So R2 dash is equal to R2 by minus 5 is the operation. That is, so this is same 1, 2, 1, 0 same. 0 divided by minus 5 is 0. Minus 5 by minus 5 is equal to plus 1. And 1, 0 same. Minus 2 by minus 5 is 2 by 5. And minus 1 by minus 5. Plus 1 by minus 5 is minus 1 by 5. Now, so it is 1, 0, 0. 1, 0, 0, 1. So already 1 is there, 0 is there, 1 is, so convert this element as 0. For that, what we are going to do, this is the operation. That is R1 dash is equal to R1 minus 2 into R1. R1 is equal to R1 dash is equal to R1 minus 2 into R2. So that is 1. Let us take 1 minus 1 minus 2 into 2 by 5. This is same. 1 minus 0 is 1. This is remains the same. Whereas here 1 minus 2 by 5, that is 5 ones are 5 minus 4 is equal to 1 by 5. You will get again this 0. 0 minus 2 times minus 1 by 5, minus into minus plus, this is equal to 2 by 5. So 1 by 5, 2 by 5, 2 by 5 minus 1 by 5, remove 5 out. So this is 1 by 5 into 1, 2, 2 minus 1 is the inverse of the matrix denoted as A inverse. Now let us take a similar problem. One more problem I will explain so that it is very easy for you to solve the problem. So by using elementary operations, find the inverse of the matrix. A is equal to 1, 3, 2, 7. By using elementary operation, find the inverse of A. Now we know this. Let, what is the property? A is equal to I into A. Now what is A? 1, 3, 2, 7 is equal to an identity matrix 1, 0, 0, 1 into A. So 1, 3, 2, 7 is equal to 1, 0, 0, 1 into A. Now what is the intention is to convert this 1, 3, 2, 7 as identity matrix. Here already 1 is there. Convert 3 to 0, 2 to 0 and 7 to 1. For this, the easiest way you can convert this as 0. For this, let us take R2 dash is equal to this R2 minus, here 2 is there, 2 times this R1, that's all. So what are the constant present? You just subtract with that. R2 dash is equal to R2 minus 2 times R1. So here I will put the step. R2 dash is equal to R2 minus 2 into R1. So here first write on this. R1 is same 1, 3, 1, 0. Now we are converting only second row. So first element of R2 is 2 minus 2 times first element of R1 is 1. 2 minus 2 is equal to 0. So this element becomes 0. Again first element of this second element is 7 minus 2 into 3. That is 7 minus 6 is equal to 1. this becomes 1. Now this 0 minus R2 is 0 minus 2 into R1 is 1. 0 minus 2 is equal to minus 2. So this becomes minus 2. Again 1 minus 2 times 0. So that is 1 minus 2 times 0 is equal to 1. So this reduces to 1. So followed. Here see R2 dash is equal to R2 minus 2 R1. First row same 1 3 1 0 as it is. For this just subtract with 2, that's all. R2 2 minus 2 into 1, 2 minus 2 is equal to 0. Again 7 minus 2 into 3, 7 minus 2 into 3 is equal to 1. Similarly for this 0 minus 2 into 1, 0 minus 2 into 1 is minus 2, 1 minus 2 into 0 is equal to 1. Now, so 1 0 0 1 already, here convert this to 1, that's all. So convert 3 to 0. How you are going to convert 3 to 0? For this, very simple, we are going to convert R1 dash. R1 dash is equal to R1 dash is equal to R1 dash is equal to R1 minus. So what is the property we are going to use? R1 minus 3 times R2. So that is 0 1 as it is equal to second row the same minus 2 and 1, and this is A. R1 dash is equal to R1 minus 3 times R2. So R1 dash, this is first element, 1 minus 3 into 0. So what you will get? 3 into 0 is 0. This is 1. It won't changes. Again second element, 3 minus 3 into 1. So that is 3 minus 3 is equal to 0. This reduces to 0. Now here 1 minus 3 times minus 2. So that is equal to 1 minus into minus plus 3 to the 6. This becomes 7. Next 0 minus 3 times R2. What is R2? It is 1. So that is equal to minus 3. So here 1 0 0 1 identity matrix. So therefore this is the inverse. The inverse of A is equal to A inverse is equal to 7 minus 3 minus 2 and 1. This is the inverse of the matrix. That is A inverse is equal to 7 minus 3 minus 2 and 1. So usually you will get a problem like this for 3 marks. Followed. So you very simple. So this is the property. A is equal to I into A. 1 3 2 0. 1 0 0 1 is equal to A. So convert this as an identity matrix. Here already 1 is there. So it is convert this to 0 and this to 0 and this to 1. The easiest method is convert this to 0. For this we have to subtract 2 from this matrix. That's all. R2 dash is equal to R2 minus 2 times R1. 1 3 1 0 same. 2 minus 2 into 1 is 0. 7 minus 2 into 3 is equal to 6. 7 minus 6 is 1. Again 0 minus 2 into 1 is minus 2. 1 minus 0 into 2 is 0, that is 1 minus 0 is 1. Similarly, so 1 0 1, it is already convert this to 0. For that R1 dash is equal to R1 minus 3 times R2. So 1, the second row same, 0 1 minus 2 1 as it is. Convert this. 1 minus 0 into any number is, yes, you are going to get same. Again this one 3 minus 3 into 1. 3 minus 3 into 1 is 3 minus 3, that is equal to 0. Here 1 minus 3 times minus 2 you are going to get 7, and 0 minus 3 times 1 you are going to get 1. So therefore A inverse is equal to 3 minus 7 minus 3 minus 1 minus 2 and plus 1 is the inverse of the matrix. Now here next type of problems based on these invertible matrices, we are going to study regarding this type of problems. This is very important for the point of examination. Usually you will get one question from this for 4 marks. In part C for 4 mark questions you may expect this question for 4 marks in section E, A, B, C, D, E section, that is part E section. 6 plus 4 marks question is there for 10 marker. 1 4 marker question will be from this. So this is very easiest method. So if A is equal to 3 1 minus 1 2 satisfies the equation A square minus 5A plus 7I is equal to 0, where I is an identity matrix of same order, then find A inverse. See, what happens in this problem, usually students will get confused and they will solve this equation. They will find out A square, which I did in the last class, A square minus 5A plus 7I. They will simplify and prove that equal to 0. That is wrong. Actually, it is given that A is equal to 3, 1, minus 1, 2 satisfies this equation. Already it will satisfy this equation. That means the answer is 0. If such is the case, find the inverse. What is required to find is the inverse. A inverse is to be determined. Very simple. What is given? Given that A square minus 5A plus 7I is equal to 0. Now multiply by A inverse. Multiply by A inverse into A square can be written as A into A minus 5 A inverse into A plus 7 A inverse into I. 0 into A inverse is 0. Now associative property, if I apply associative property, then this becomes A inverse into A minus this is same A inverse plus 7 times A inverse into I. So we have already studied. What is this? A inverse is equal to A inverse into A is equal to an identity matrix. Right? A inverse is equal to I. This is I into A minus 5. A inverse is equal to I plus, again, we have studied this. Any matrix into identity matrix is equal to the same matrix. 7 times A inverse is equal to A inverse. This is equal to 0. Now our intention is to determine the value of A inverse. So I into A is A minus 5I plus 7A inverse is equal to 0. Now here this is, so just keep 7A inverse. 7A inverse is equal to transfer minus I becomes plus 5I and my plus A becomes minus A. That's all. 7A inverse is equal to 5I minus A. If we solve this much, the remaining is easy. So you see here once again, multiply by A inverse. This is given equation. The given equation, A square minus 5A plus 7I is equal to 0. Multiply by A inverse. A inverse into A square can be written as A into A minus 5A A inverse plus I A inverse into I. Using associative property, this can be written as A inverse into A. This is same A inverse A plus 7A inverse into I. So you know this property, A inverse is equal to A inverse into A is equal to an identity property. This is I into A. This is A inverse is I. A inverse into I. If you multiply any matrix with an identity matrix, again it is same matrix. A into I or A inverse into I is equal to A inverse itself. I into A is A. 5I plus 7A inverse is equal to 0. What is required to find is A inverse. So just keep A in 7A inverse and transfers. Minus 5I becomes plus 5 and minus A. Now substitute the values here. 5 into, identity matrix of same order is 1 0 0 1 minus A. What is A? Given matrix 3 1 minus 1 2. So this is equal to 5 ones are 5 0 0 5 and minus 3 1 minus 1 2. Subtract this. 5 minus 3 is 2. 0 minus 1 is minus 1. 0 minus into minus is plus 1. 5 minus 2 is equal to 3. So this is the inverse of the matrix. This is the method. This is how you are going to find the inverse of a matrix. This is the method to solve this problem. Don't prove that A square minus 5A plus 7I is equal to 0. So this is the easiest method. So if you do this much, you will get 4 marks in part E section. Now coming to the next problem. Same type. Let me solve one more problem. Now if A is equal to 2, 3, 1, 2 satisfies the equation A square minus 4A plus I is equal to 0, where I is an identity matrix of order 2 cross 2. 0 is a null matrix of order 2 cross 2. Using this equation, find A inverse. Same. So let us give an equation. Write down the given equation. Given equation is A square minus 4A plus I is equal to 0. So multiply by A inverse. A square can be written as A into A minus 4 times A inverse into A plus A inverse into I is equal to 0. Now using associative property, A inverse, this interchange the brackets, that's all. A inverse into A minus, this is same, 4A inverse into A plus A inverse into I is equal to 0. Now, so you know this property, A inverse is equal to A inverse into A is equal to an identity matrix. This is an identity matrix into A minus 4 into A inverse is an identity matrix. Again, you know this property also, A inverse into I is equal to A inverse. So this is A inverse is equal to 0. Also you know this property, I into A is equal to A. I into A is equal to A minus 4I plus A inverse is equal to 0. Now what is required to find is A inverse. So A inverse, transfer this minus I becomes plus 4I and plus A becomes minus A. Right, that's all. So if we simplify this, we will get the answer. Check here, see, given equation is A square minus 4A plus I is equal to 0, pre-multiplying by A inverse. If you multiply by A inverse into A square can be written as A into A minus 4 into A inverse A plus A inverse into I. Since using associative property, interchange the brackets, A inverse of A into A minus this 4A inverse plus A inverse into I remains the same. Since you know the property, A inverse into A is I into A minus 4 into A inverse into A is equal to an identity matrix that is equal to I. Yes, A inverse into I is equal to A inverse. I into A is equal to A minus 4I plus A inverse. Now therefore, A inverse, just keep A inverse here and transfer minus 4I becomes plus 4I and plus A becomes minus A. Now substitute the values. 4 into it is given. I is an identity matrix of same order means 1, 0, 0, 1 minus A. What is A? The given matrix 2, 3, 1 and 2. Now multiply this. 4 into 1 is 4. This is 0, 0, 4 minus 2, 3, 1, 2. Simplify this. This is equal to 4 minus 2 is 2. 0 minus 3 is minus 3. 0 minus 1 is minus 1. 4 minus 2 is equal to 2. So therefore, A inverse is equal to 2 minus 3 minus 1, 2. See, what are the elements? Whatever the elements here, the same elements you will get. And the inverse, and to verify very easiest method is the diagonal elements will remain the same. Interchanging the diagonal. If you interchange the diagonals, interchanging of the diagonals and changing the signs for this secondary diagonal will be the answer. So 2, 2 minus 1 minus 3, this is the correct answer. This is the inverse. So therefore, A inverse is equal to, what is the value? 2 minus 3 minus 1 and 2. So usually this type of problems you will get in the examination for 2 marks. Now, so that is regarding today's session. Still I have one more session. In that we will discuss the miscellaneous problems. Thank you.